All right. In our last video, I explained why it rains in general terms. Whenever you have air moving up, this was the big takeaway. When air moves up, you should always expect clouds to form and rain. So whenever air moves up, you get clouds to form and you have rain. That's called adiabatic cooling. So we're going to see, we're going to draw this at a more global level. So I'm going to draw a big Earth. Okay, there's a big Earth, and on our diagram, this is going to be the equator. Okay, now usually we put the equator off on the side here, but this is where the action is happening, so I want to make sure we draw things here. Now, you don't need to draw these lines. In fact, don't draw these next lines, but we know that the sunlight is coming down, parallel rays from the sun, right? Parallel rays from the sun. And at the equator, they're hitting the Earth at a right angle, right? That's a 90 degrees, totally perpendical. Over here, you know, this might be a 45-degree angle, and over here, it might be a 10% angle. So that's why the sunlight is much more intense here, because it's not spread out as much. So it's always going to be hotter at the equator. And so again, we have that unequal heating of the Earth. And so today's video here is going to show the ramifications for that. So we're going to write here, this is where there's the most sunlight, at the equator. And because we have more sunlight here and it's warmer right here, what's the air going to do right here? It's going to move up, right? Because hot air rises. Hot air rises, right? And as hot air rises, it expands and cools. Expands and cools. So this is exactly the same drawing we drew before. And at some point, right, we have the RH as it's going up, right? As the air is going up, you have the RH increasing until you hit, right, that magic level here. This is the condensation point, right? You can also call it the saturation point. We call it the dew point. And we know that when we get to the saturation point, we get clouds, right? And we get rain, right? And that's why it rains at the equator, because we have all that hot air moving up. Hot air moving up is always going to cool. RH is going to go up. We're going to get that saturation point reached. Clouds get made, and that's adiabatic cooling that we got. So that's our same diagram, but let's see what happens. This air can't keep on going up into space, for gravity is going to bring it down, but also it's different air now. It's cooled off. It's really far away. And so what happens is it's going to go to the sides, right? Because that's the only place it can be. But how is this air different than this air? Well, it doesn't have as much water anymore, because we just lost a lot of that water from rain. And it's starting to cool off, right? So this is drier, cooler air. And drier, cooler air is more dense. So this air is getting more dense. And we know that dense air is going to fall. Okay, so if the RH goes up when the air goes up, right, because the air is getting hotter and hotter, what happens, our air is getting cooler and cooler, and it's expanding, or as you say, it's expanding and therefore getting colder. Here, what's going to happen to the air? Well, we're going to have, the air is going to get warmer and warmer, because it's going to be, going through air that has higher pressure, so it's going to contract and do exactly the opposite of adiabatic cooling, and so we're going to get adiabatic heating, right? And the most important thing to know about adiabatic heating is that as the air temperature gets higher, the relative humidity is going to be going down. Ain't never going to get to 100% relative humidity if your RH is dropping. So when this air makes it all the way back to the ground here, right? First of all, it's going to have to go this way, or it's going to have to go this way. What's going to be happening right here? And actually the same thing is happening on this side. And this air over here is going to go this way and go that way. This air is hot and dry and has a low RH. So what kind of area would you expect this to be? You expect it to be desert, all right? And that's exactly what you get. You get these things called desert belts. And they're at about 30 degrees north and 30 degrees south, where this air is really dry. It's warm and it's dry. And so these right here at 30 degrees north and south of the equator, you get desert belts. And you have the great deserts, the Saharas, the Sonoran Desert, and we'll see that on a map. So this is warm, or actually hot, dry air right here, hot, dry air. So this is a convection cell. Hot air goes up, and then the cold air comes down, and it just keeps on going around in a circle. And in fact, there's two of them. There's two of them. All right. I would think of convection as two circles going like this, up in the middle, come around, and that's how your room is heated. That's how a lot of things happen. There's a name for this. This is called a Hadley cell. Right? Both of these are Hadley cells. All right. That's a Hadley cell. And so because we have these Hadley cells, we have very predictable weather around here. We know it's always warm and wet here, but we also know the winds. We know the winds are always going to be over here. We call these the trade winds. They're always moving from here to here. And we know this is an area of low pressure. Low pressure because the air is going up. It's not pushing down on you, adding to the pressure. That's an area of low pressure. And this is an area of high pressure, because besides all that gravity pulling down on the air, you actually have the air moving down. Now, we don't call air moving down or up wind. We're never going to notice those things, but we will notice a drop in pressure or an increase in pressure. This is where there's wind. So this is wind, okay? So we have these winds, right? You don't need to draw those down. Okay, so let's continue this picture because there are some other patterns. These winds are going to continue this way. And then this isn't as in stone, but at about 60 degrees, this air gets heated enough where it's going to start going up again. All right. And as you go up, you know that you're going to have adiabatic cooling, right? So the RH is going to go up, and you're going to have a little bit more rain. But it's not as this low pressure here, right? This is another low pressure. This low pressure isn't as strong as this one, so this low pressure can move around. But in general, you have the air, and at the top it can go both directions. And then it cools just like regular, and eventually it's going to make it down. And even though we're close to the poles right here, this is air going down. So you're going to have, you're going to have some clouds here and some rain. But over here, this is dry air, right? This is really dry air over here. And when it comes down, it's going to get drier and drier. And so this is a high pressure. You're not going to get a whole lot of weather where there's high pressure. And I don't know if you guessed the latitude here, but this is 90 degrees. This is the poles. And this is why the poles are some of the driest areas. Besides being really cold, and you know that cold air can't hold much water, it's also a high pressure, and air is moving down. You're never going to get any weather. So this right here is also called this is a polar cell. This is an area where, well, like I said, right here is where it's very predictable weather. All this area is very predictable. We've got these deserts, we've got these trade winds, we got the equator. Once you go over here, this area kind of moves back and forth. And so this is a little less predictable. But you're going to get, this is where the big forests are. At about 60 degrees, we have cold forests that get a lot of rain, though. But this is much more unpredictable weather, right? So we're gonna write that down here. This is kind of variable winds. not as predictable in this area. And I don't know if you remember hearing about in the last few years we get the polar vortex, and that's when this polar cell is sort of moving around. So there's a lot going on there. Again, we're using that adiabatic heat, cooling and adiabatic heating to explain why we get rain here, why we have deserts here. And again, even the adiabatic cooling here, we got a little wetter weather at about 60 degrees and adiabatic heating down here at 90 degrees. So we have all of this. And so this really is explaining Hadley cells and desert belts.